Okay, so let's see what we're going to do for the lab report, the distillation. So here's a picture, a copy from Wikipedia. Shows different things. I'll repeat myself. So we have basically a round bottom flask. So this round bottom flask include what we're going to distill. Let's say we have a mixture of acetone and water, and we want to distill that. And then we have to have a heat. So this is really some kind of oil or heating bath. And then we have a stirrer. So the liquid during the distillation gets mixed. The heat makes it vapor. So the vapor goes up the column. So we have a little bit fractionation here. So fractionation is when we want to separate probably water from the acetone. Then it goes to a thermometer. So the thermometer tip is really right here underneath this Y adapter. So remember we have a Y adapters here. So now what thermometer does basically reads the temperature. What does it read? Read that vapor pressure temperature. So at this point the vapor pressure and liquid temperature are equilibrium. So what we do, we're converting a liquid to vapor or boiling it, and then it goes to the condenser. So this is what we call a condenser. So condenser job is to convert the vapor to liquid. What we're going to do, we're going to use water. Look, the condenser is really has a jacket. So what the vapor goes inside, it doesn't really get mixed with the jacket. Jacket is separate from the vapor. But the jacket gets cooled by water in, water out. So during this time, the vapor changes from vapor back to liquid. And then liquid gets here and we collect it here. Typically, if the vapor is hot and the liquid is slow boiling, we have a little bit of ice cubes and everything here. So here's again, this I didn't want to make it too uh, busy, but we need to look at this distillation even though we're not in the lab right now. Again, we have the heat source and the stirrer source, round bottom flask. Typically in the lab, we have a round bottom flask. Liquid gets hot, it vapors, and vapor comes here. So that's the location of our thermometer. And this Y is connected to a condenser. It's connected to a condenser. So this is a condenser. Water in at the bottom, number 6. Water out, number 7. So we always put the water in and water out, because if you put the water out from here, water in from here, it doesn't have enough time to cool the vapor. But on the other hand, if you put it here, the water goes up and it has time to cool the vapor. And water runs the whole time that we're doing a distillation. Now we're not going to talk about this part, but we have a little adapter and there is a little opening here that we can use it again for a different lab that we're going to do a reduced pressure distillation. Right now we're doing atmospheric distillation. So we're not having anything here at number 9. And then we collect our product. So let's say we have a water and an acetone here, and we want to distill that. So the acetone is much lower boiling point than water. What does that mean? So let me put my other paper here. So if I look at my paper here, and we can have the same thing for water. Maybe make it a little bit bigger here. Yeah, that's a little bit better. So put this down a little bit so I can adjust it on the document camera. So here is the temperature at the x-axis. We have the temperature. Y-axis we have pressure. So we have the pressure we have temperature. Now, what is the boiling point? So boiling point is when the vapor pressure of this, let's say acetone. So we have acetone here, CH3, CO, CH3. So we want to be at, remember atmospheric pressure is 760 millimeters of mercury, which is 1 torr. So that's the unit, right? 1 torr, 1 atmospheric, or 760 millimeters of mercury. So we're looking at I'm sorry, moving the paper. So we're looking at 760. So this is 600, 800. So if I use a ruler, so if I use a ruler, I don't know what exactly it is. I'll say somewhere here. So I draw a line from here to here. This is the curve for the pressure, right? Then I draw a line down here. Got a little bit off, but typically I would have done a better graph paper. So this would have been 56 degrees C, and that's where the acetone boils. So acetone boils at 56 because at that temperature, the vapor pressure of acetone is 760, which is atmospheric, and that becomes vapor. Now, if you do the same thing for water much higher temperature. So let me use it. Maybe use a different color here. So if you do the same thing for the vapor pressure for the water, so you can see the water at 100 degrees C has a vapor pressure of 760 and it boils. So now we can see that we can separate acetone from water because they have different vapor pressure at different temperature. Acetone boils first because it's higher pressure. It has higher vapor pressure. Water boils later on because it at 100 has 760 vapor pressure. So vapor pressure and boiling point are related. So I think by doing a little bit of explanation right now and a little bit fractionation, talk a little bit about fractionation. So fractionation is this length of this column. Higher and longer this column is, it gets a better chance for the two components to separate from each other. So if you have a good fractionation, we can water and acetone separate from each other. If this column here is very short, there's a good chance when we boiling acetone over and distilling acetone over, some of the water would come along. So we don't get a good separation. So a good separation comes from a good fractionation. And if you do what we call a simple distillation, they might not separate from each other. Distillation is used many ways for the making gasoline for the car, making whiskey, and many others. Now, when we're doing distillation, we should not let this all the way water and acetone or anything else we have here to go out, because if you heat the system empty, there's a good chance that either explode or catch fire. So during the distillation, we always leave a little bit of the liquid back, and we don't distill everything. I hope this helped you with the write-up for this distillation package. Thank you.